Let me go back to week 4. So we're going to look at a loop, and we've already started peeking at them. Click. Well, we're going to also look at some nested loops. And this gives us some ability to do something really, really powerful. Have any of you guys used a clock? You guys have all used a clock? You guys have used nested loops. And so we're going to show you an example with a clock really quickly about what we're talking about. So not only can we do something similar to our coin flip where we're just flipping a coin back and forth, but we can actually do some really powerful things. So we talked about, let me just go through this way real quick. We talked about loops. We talked about definite and indefinite loops. In other words, we want to run it a certain number of times. So if we ran our coin flip program, we'd want to run it a definite number of times, probably. We wanted to see what happens if we flipped a coin 1,000 times. That would be a definite loop. If I were instead, though, searching to see if I could find 5 heads in a row, do I know how many times that I have to flip a coin first? No. That would be an indefinite loop. It would be using that while. So while we still don't have 5 in a row, we're going to keep searching through that loop. So we talked about a sentinel value, something that we have to change so that we can get out of that loop. Because if I don't have a way to get out of that loop, I have what's called an infinite loop. And you've seen that in several movies. They use it as a plot line of, oh, I made the computer go in an infinite loop and it exploded. Oh, well, maybe not. But the reality is we can get a loop running, and if we never get out of it, it's not going to do us any good. We're going to start with this idea of nested loops. So nested loops are the idea that we put one loop inside of another loop. And so here's the idea of a bank balance program. Let's see where we're at here. So let's do a couple of things really quickly. I'm going to fire up Notepad, and I am going to build us a loop. And I want to build us a clock. So we know we have to have a start, and I know I have to have a stop. And I probably need some variables in there. What variables might I need for a clock? Well, I might use time, but let's do this one. Let's do seconds. And if we're going to do seconds, let's do minutes. And let's do hour. Do we want to get crazy and do a day? Let's put it in there just in case. All right, so there's our program. And we want to have a clock that runs. And so the first thing we're going to do is we're going to have our clock loop and do seconds and put it up on the screen. All right, so we want to have a loop. So while, and here we could cheat a little bit. So while seconds less than, when does a second end? So while less than 60, would that make sense? Okay. While seconds are less than 60, I am going to do something. So I'm going to output seconds. End while. So I made a loop, and as long as seconds are less than 60, and so I better go up here and I'm going to say equals 0. So right now, seconds are going to equal 0. It comes through here as 0 less than 60. So it's going to output a second and say 0. And then it's going to loop and do that again. So what am I missing in there? So I don't have any way to change that value that I'm basing this on. So I'm basing it on the value of seconds. I don't have anything to change that. So what if I added this? I said second equals second plus 1. Now I have one other weird thing that we're going to see. So let's think about this as this runs. So this should run through and count down 60 seconds, right? What is it actually going to put on the screen? So I'm going to come down here and say, this is what I'm going to see. So the first time that loops through, what second am I going to see? Am I going to see 1? So let's think about it. 0. 0 is less than 60. Output seconds, which is 0. And then the next time it loops, what am I going to see? And then 2, and then 3, and then 4. And then it'll go on till what number is the last second I'm going to see? 59. So that seems to make sense. If you ran a stopwatch, that's kind of how it works, right? Looks accurate. So we now just built a loop that did our seconds. At the end of our seconds, you could even have an end piece out here that says, congratulations, you made it to a second, whatever it is. We did one minute's worth of seconds. What if we wanted to add minutes in there? So think about those old clocks you've seen. Have you guys seen those like old alarm clocks where the minutes are spinning over here and then it's got another number? Or just think about what happens in general. What happens when I reach 59 seconds and I start over? What changes? The minute changes. So my minutes are going to be a loop around those seconds. So bear with me and we'll see if we can figure this out. So we're going to set a second loop up. So we're going to say while minute, I'm going to call it minute. I don't know why I have minutes up there. Let's just call it minute. So while minute is less than, how many minutes are there in an hour? 60. So we can use kind of a similar logic. Now, here's where it's a little tricky, and Notepad++ would be nice, because we can take a whole block and indent. But these things all happen inside of 1 minute. All right, so we have a minute that's going to occur. So while minute is less than 60, I am going to do end while. And you could make notes on here, and it's not a bad idea when you start doing those nested ones. You could say end of minute loop, and then you could do this one as end of second loop. So you could do those to keep track of where you're at. Because quite frankly, when you start getting these nested a couple levels deep, it does get a little tough to deal with. But our minute then says, while minute is less than 60, we're going to let this run. Okay? So everything in here, this is that indented code block. Most of you saw comments on your stuff so far about make sure you indent code blocks. Because the computer says, I'm going to run this loop here. Everything in this block is what runs inside of there. And it's indents that control that in almost every programming language. So here we have our block. And our while loop is going to run inside of that. Well, that makes sense. So what are we missing in here? Are we missing anything? So we want our clock to display minutes and to display seconds. What else do we need in here? Well, I probably should output that minute. Output minute. And so it's going to say minute 0, second 0. Next time this loops through, it's going to say, leave that 0 up there, and it's going to say the seconds are going to scroll through. So what else do I need in there? Or what am I missing, I guess, would be a question. So what's going to happen in this loop? Is it ever going to change that minute value? No. So what do I need to do to change that minute value? Okay, so I could do minute equals minute plus 1. And so that will hopefully start scrolling up. So there's one other piece in here that we have to have. So let's do a desk audit. Let's kind of see what happens. So as we start this, and sometimes this is a great way to do it, you can just scribble down. We start this program. Right now, minute and second are both equal to 0, right? They come in here. Is 0 less than 60? We output the minute, so we output 0. We add minute and give it an extra 1, so it says minute is equal to 1 now. And sometimes it's easy just to track this like that. Our second is equal to 0 when we come in here. So second is less than 0, so this inner portion is going to run. So it's going to output a second, so it's going to say 0. It's going to add 1, and it's going to run this loop 60 times, right? So it's going to count up the seconds between 0 and 60. Then it's going to end that loop. When it gets to 59, will be the last one that runs. When it hits the value of 60, it's going to exit. So at this point now, our minute is still equal to 1 now. Our seconds are equal to 60. We've gone through this piece of the loop and it's exited out. So we ended our second loop. It loops back up to the top of our while loop. Is 1 less than 60? I hope so. So we output the minute. So it outputs 1. Minute equals minute. So now minute is equal to 2. And now it runs this loop. And it says, while second is less than 60, but our seconds are still at 60. Is 60 less than 0 or less than 60? No. So it doesn't run this loop at all. So what am I going to have to add into this particular program? What do I need to add? Okay, so if I added a line right here, and I said seconds equals 0, is that going to reset then every time this outer loop runs? And that's what we want to have happen. We want the seconds to reset, so the inner loop gets reset every time the outside loop runs. So now we can display, so now we have our minute equals 2, our seconds equals 0, until it hits that line, and then it goes seconds equals 0, it comes back in and it runs this particular loop, runs through our seconds. So now we have a counter that we can count minutes and we can count seconds. And that's that idea of that nested loops. You guys have all used them. You know how we reset. It's just working through the logic of how you can do that. So if we can do that with minutes, can we then add hours in there? So we could do something very similar. So while hour is less than, how many hours are in a day? 24. So while hour is less than 24, then we're going to do a code block. And so all of this, we need to go in and indent it one more time. And again, that's where a more powerful tool like that Notepad++, you can just select that entire set of lines and indent and it will work. So while hour is less than 24, and then inside of there, so we have some very similar structures. So we know we're going to output hour. And out here then, we probably should change something. So hour equals hour plus 1. And if we want that minute loop to run and reset every time, I need to set then minute equals 0. And so now if I work through this, I can run seconds. Every time that seconds hits 60, it triggers a loop of this outer loop of that. So we have 3 separate loops here now. They're all nested inside of each other. So as this one runs 60 times, then it comes back out to this outside loop. And then finally out to this outer loop of hours. So here's a little question. If I add a variable in here, and I'm going to do one more piece in here, and I'm just going to add something like counter equals counter plus 1. Because I want to know every time that inside loop runs. At the end of this cycle, how many times is that, what is that value of counter going to be? So I'm not resetting counter. It's going to just add up every time that that runs. So how many times is that inner loop going to execute? That code block here. At the end of a day. So at the end of the first minute, how many times does it run? 60. All right. At the end of the first hour, how many times is it going to have run?
60 times 60?
Because it's going to run 60 times for every one of this loop that runs. And then if I take it times 24, so my counter at the end of this cycle, when this loop completely exits, it's going to have run 60 times for every 60 minutes. So in other words, it's going to show me how many seconds there are in a day, right? Yeah. So now, if I added a day loop, I could do the exact same thing. I could put that loop, so I could nest these 4 layers deep, 5 layers deep. So I could put day, I could put years, and so it's a cyclical counter, and it resets every inside piece. This is probably one of the tougher things we're going to do, is how do I work with those? But we work with them with a lot of different aspects. So time is one we can see and we can use a lot. We know that we have things that happen all the time in our lives. And your example in your book this week for your assignment actually has to do with something particularly horrible that most of you haven't done yet. And that is that idea of a mortgage. Ugh. How often do you have to pay a mortgage? Monthly. So every month for a huge number of years, you pay on a house. Well, some of you may already have car payments. How often do you pay a car payment? Every month for so many years. So if I'm thinking about I'm going to do a car payment, so let's set up a couple of examples for that. So we're going to do this is our car payment. So let's get a couple of values in there. So I'm going to do a start, and I'm going to declare payment. And because I know that that payment has a value that's going to not change over every month, let's put a value in there. What's an average car payment, you think, in the U.S. right now? $325?
For a car, if you're doing a truck, you're going more 500.
I'm going to bet if we look online, if somebody wants to do that, look up average car payment. I'm going to guess we're more around $550 right now. Because people are paying a lot of money for a car. I could be wrong.
Maybe it depends on the down payment.
It does depend on the down payment. We're just kind of looking for a number in here for now. But
530.
$530 is the average for a new U.S. car.
And 381 for.
Holy cow. All right, let's split the difference and let's just call it $400. Unless you're cheap. And then it's $399. All right, so your average payment, $400. how many years do we have for that?
It's 5 years.
And so most people pay a car loan over 5 years. So,
Some are doing it longer, so you have lower payments.
true. So we're going to go through and we're going to write the logic for them sending out, or you're sending them a payment every month. So unfortunately, I need another thing in here. So I need months. How many months in a year are there? All right, good. All right. Everybody still remembers how many months there are in a year. That's good to know. All right, so we know that we're going to pay all the way up to 5 years, right? So we can set up our outside loop. So while months. Now we already set up at the top that it's already set to 5. So do we need to change our logic a little bit here? Because if I said while it was less than a certain number, so if I said it's less than 5, is this loop ever going to run? So instead of adding, do we need to think about our logic a little differently? So while months, we're going to start with 5 and we're going to go down, right? So how about if we said while months is greater than 0? So we start out, or actually let's do that as years. How about that? Let's do the outside loop first. So while years greater than 0. So in other words, we're going to count down every time. And so the first thing we might want to do is we might want to say year equal year minus 1. So if it's made it all the way through this outside loop, we're going to take out a year. What do we need to next put in there, you think? Put some space in here. So while years are less than 0, and we can run that, so the first time we say 5, is 5 greater than 0? Yep, so we still have to pay in that year. So we also want to probably figure out what the month is. So we know we're going to have an inside loop based on the month. So while month greater than 0, so we can use similar logic. Month equals month minus 1. Make horrible payment. So do we need to do anything else on here? I've got in while stop. So we have a nested loop. So the first thing this does is comes through and says while years are less or greater than 0, year equals year minus 1. So at the first time this comes through there, year gets set to 4, right? Month gets set to 12 equals 12 minus 1, or 11. We make a payment, and it loops back up here again, right? So this actually should be nested inside of there, so we know that it's a code block. And then it runs this piece again. Once this is ran through 12 months, right? So it's going to go 11, 10, 9, 8, 7, 6, blah, blah, blah. So now we have one problem. It comes back up here again, so we take out another year. Did we change month up there? So we need to reset the value of month. And in this case, we're not going to set it equal to 0. What are we going to set month equal to? 1? There's only Well, that will force that loop around once. But what if we set it equal to 12 again? Because in this case, remember, we're counting down. We can do the logic either way, but you could either count up, count down. So now, let's think about what happens. We went through this whole cycle. So it went all the way down to 0. We come back, so that kicks us out of this loop and kicks us into our outside loop. So our outside loop was at 4, and it's going to now go, oh, I'm going to change that to 3, because 4 is greater than 0. So now year equals year minus 1, so now year is equal to 3. Our month, we set it back to 12, and 12 is greater than 0, and so we cycle this inside loop another 12 times. So hopefully at the end of this, how many times are we going to make a payment? 60. So you can multiply the number of times you count the outside loop times the number of times you do that inside loop to figure out how many times you create a complete loop. So there we've set up our payment plan, and you're paying that bank, what are you paying? $400 every month. So that's an example of that idea of a nested loop that you have in there. And you're going to use that quite a bit. So what kind of things? And we've already ran into a couple of those. So if we didn't initialize or give that loop variable some kind of special value, initialize it, we can have a loop issue, and we did that. If we don't put in a way to alter that loop control variable, so if we don't put in something like this, year equals year minus 1, or second here equals second plus 1, our program is going to fail because we're going to end up in that infinite loop or never execute that loop the second time. We also have to worry about if you use the wrong comparison, and sometimes people will do that. So the other one that these blocks make life a little easier is making sure that the right statements are in the right block. Because if I put in here out of sequence somewhere, or I forgot to indent that, that's not going to run as this block here. It's going to try to run it on its own. And so you have to make sure you use those indents. Those tabs are your friend in here. So, for example, here's an example of one that you have an issue for, and several issues actually. So, down in the pseudocode, we have our declarations. So here we declare a name. We have a numeric called production, a label counter, and a string for label text. So again, that's a constant because it's all capitals. And quit. All right. So while name is not equal to quit. So in other words, while name not equal to quit. So we declared it. There's a name. We don't know what's in there. As long as it doesn't equal quit, we're going to run this loop. So, come back. So, we have to be careful here because what we didn't do though, did we get a value, initial value for that? Did we ask him for it? No. We also down here then, while label counter not equal to production, all right, production, label counter, I don't see where we have any value for label counter. Output label counter equals label counter plus 1. So we're going to add that value over and over again. So here we show it on the flow chart. We're going to add it, but we don't know what label counter begins at 0. Maybe it's stuck at a value from a previous loop. We don't have any idea. Initializing those values is really important. So here's another example of a loop here, and this loop goes bad because we say is label counter is equal to production. We output the label and we make a loop. Well, and here we did say label counter is equal to 0, but do we ever change anything in this loop? If we don't alter something in that loop, then we'll never get out of it. That loop will run forever. This will spit out output labels until it runs out of paper and then sit there and blink at you if it's actually printing things like a production label. So we have to be careful about those. This is that idea of these comparisons that can go wrong. So let's take a look at the left and the right. So the left says while counter is less than 10, output hello, counter equals counter plus 1. All right, that looks like it would work. And we've already established that that computer starts counting at 0. So we think that that is actually going to put out 10 cycles. And you can run the desk audit and you can do that. And so the first time it's through, it's 0, prints out a label, and adds 1. And so you can keep track of those and count them. The less than or equal those two is going to allow it to actually print not 10, but how many labels? 11, because it's going to actually have one more that we're going to have in there. So the other thing we see a lot of, is putting in a statement inside of a loop and running it over and over and over again when it could have been done outside of that loop body and only run once. So here, for example, we see that weekly pay equals hourly pay times hours per week. Well, that makes sense. You work how many hours times how much you make an hour. So here, though, every time we run this loop, we're recalculating the same value for weekly pay. And we could have put it in there, ran it once. It's just an extraneous thing. It's not going to come up with a different value in this particular case, but we have to be careful. You're just running it over and over again. And so we see that a lot. So here is a shortcut. So we already figured out we could do a loop. We could print out something 10 times pretty easily. We could do a while loop. And you can do everything in this class till the end of the semester, and you can do everything with a while loop. But I want to show you a slightly easier way. And almost every programming language has some structure similar to this. Because we can use that while loop. It's perfectly valid. And in fact, internally, the computer does a while loop even when you set it up this way. But this just makes life a little easier. It's cleaner, and it'll do that loop on essentially one statement. That makes life easy. And it's something called a for loop. So when we use a for loop, we do this. So we say we're going to do for something to final value. So in other words, if I'm going to count seconds up, so I'm going to say for 0 to 60 step 1, and then I'm going to do that loop action. So everything we do could be done with a while loop. This just gives us an easier way to do it. A really simple, easy. So here, if I want to display for years 2010 to 2100 by 10 years, I'm collecting census years or census data that happens every 10 years. I've written this for loop. It's got all those pieces in it. All I have to do is put an in for. So I don't have to put that increment. It's already built in. It says, all right, step 10 or step minus 10 if I'm going backwards, or step 1. And then everything I do is in this indented block, so I can have a line of code. So our clock example, where we know how many times a clock runs. 60 seconds in an hour has been around for a while. It's probably not going to change anytime soon. There probably is some group that would like to change it, but it's not going to happen, I don't think, very easily. So this would make us an easy way to do that clock. We could do that clock with 3 for statements, right? Yeah. For second equals 0 to 59, step plus 1, right? And then it's going to give us those values. And what's also nice is we could even do it where we can eliminate that little issue of the computer counting differently than we are. Could I say for second equals 1 to 60 and still get the same result? Yeah. And then it just blocks everything in there. So I encourage you to look at these. And when we do start working in Python here in a little bit, you're going to see that that works very nicely because it's a great way to just put in a single line and run a loop. These are only good for definitive loops. I have to know exactly how many times I'm going to run them. But a lot of times we do. We know how many times we can do things. And it's already predefined. So we know we can do that. So we looked at an accumulator already. So when I put in that counter in my clock, so I could keep track of how many seconds there are, that's an accumulator or a counter. So in there, all I did was added it in, and it's pretty easy to do. So our book talks about that. But we can also use it not just to add up seconds. Think about where we're adding in totals. We have a customer coming through and they're putting items in their shopping cart. That accumulator can be a way we can keep those totals running. So I would like to have sold all those properties, right? Get the commission. But it's a way we can total those things up inside of our loop. So we will see them quite a bit. So here, for example, that same type of thing. So here we're getting in the addresses. So we output our headings for our report. We input address and price. So they say, here's the address, here's the price. Is that the last item in our list? If yes, it says I'm going to output my accumulated total. And if I haven't ever put a value in, those are both going to be blank, right? But if I have an item in there, maybe I've sold a house this month, it's going to say, all right, here's an output and a price. And then it just adds up accumulated value equals accumulated value, not plus 1, but plus that price that we're putting in every time. Works the same for things like shopping carts. Really handy way we can do that. So, other things we can do is we can sometimes validate things. So when somebody puts in data, we want to make sure that it's in a range that fits. So think about if you were in a calculated form. You're on a web form on our website, and you're trying to put in your birthday. And you put your birth date in as you were born in 1689. Is anybody in here a vampire? You probably aren't really born in 1689, right? So we can validate by using a loop to check. And what that'll also let us do is we can re-input. So here we say input month, input day. We check them and we say, oh, those values don't fit, so re-enter them. And if they don't fit again, we can cycle that over and over and over again until you put in the right values. So we can use it as an input validation tool. So you have that priming input. You put in your data on that web page. If it doesn't match what you're trying to put in, you can loop it over and over again. And so it's a great way we do that all the time to try to control what people are doing. So these loops are the most powerful thing we're going to work with. Everything else in this class is interesting, but loops allow us to do things over and over and over and over again. So, a couple of terms. Remember that idea of sentinel values. Sentinel value is what we are basing that loop control on. If we don't change it, or it's got an ability to change and be checked, that loop does what's called an infinite loop. It's going to run forever. And we'll practice some of those, and you'll see what some of those look like when we start working in Python. A definitive loop means we know how many times it's going to run. An indefinite loop means we don't know how many times it's going to run. It's based on something that's going to change. Loops that are nested are powerful. Use that documentation, though. Use those comments so that you can keep track of where they're at. You have to use blocks. All of our languages, in fact, the one we're going to install in about 2 seconds here, requires you to use blocks. There are a few programming languages that don't, and they're ugly and hard to use, and we want to make life a little easier for you. Those blocks will show you what's going to run in each particular area. All right, so what I want to do is we're going to install the programming environment. We're getting about there. We're about ready to launch into what we're going to use, and we're going to use a programming language called Python. You can't log into the computer. It would be broken. I would try that. All right, so we're going to launch Python and show you what it looks like. So there's a couple of things about this website that are pretty exciting. So I need you to open up a browser, and it really doesn't matter which one. So here's the good news. If you have a Mac, there is a version of Python out there for a Mac. If you have a Linux machine for some reason, there's a version there. If you want to put this on a tablet, you can actually run Python compilers on tablets. You can run it on your phone if you really wanted to torture yourself. I would not advise that, but there are versions of Python for about everything. So Python is actually a fairly large language. It is what we call a high-level language. It's very much like English, and you'll see some of that. It can be very powerful. Have you heard of Dropbox? Dropbox was actually originally written in Python. Now there's some other extensions and some other pieces. But even if I look at jobs, so I'm going to click over here on the right, and I'm going to say, oh, there are people wanting programmers all over the world. So Malta, California, Mexico, London, Seattle, Washington, New York, Chicago. So this is a really popular programming language. The other thing that will help is once you have one language down, it'll a lot of times transfer to other types of languages. So I'm going to go back to the home page. So this is the authoritative page where if I want to find out something, I can find all kinds of things in here. So if I want to see success stories, hey, they're here. Using Python to do all kinds of things. If I want to find out more about Python, so notice over here on About Python, there's all kinds of things. Beginner's Guide to Non-Programmers. There are more tutorials and things on this website. You could spend 150 hours and not touch all the content on this website. This is the authoritative place. These guys develop Python. So any question in here, this is the place authoritatively to go. Sometimes it's not the easiest to read, so I'm going to suggest that there are a lot of other places also, and we'll look at some of those. So documentation. So there is documentation all the way through here, and this is where it gets a little odd. So notice over here it says docs for 3.x, so that x just stands for any value. So version 3 and version 2. So there was a big fork, and there's some differences in how code works in version 2 and 3. There is still so much installed of version 2 that people have written code that isn't necessarily been ported over, that there's still a lot of things you're going to run into in version 2. We're going to work with version 3. It's the latest version out there. That's what's moving forward. But I want you to be aware of that. So if you go online and you're looking at code samples and it looks different than what we're doing, it probably is in version 2. So there's just little subtle differences, and we'll see some of those as we go. So I'm going to go ahead and click and download it. So over here under downloads, it should identify your version of operating system. So I'm going to download the version 3.72. But notice already what's happening with Windows XP. It's going away. And there's already versions that won't run on that. So I'm going to click download. And it's a giant download. It just took all of, well, I guess it's going to take a few more seconds. It shouldn't take very long at all. This is a small, fast program. And best of all, what did it cost you to download it? Not a thing. So even better. So once it's downloaded, I'm going to run it. And I'm going to install now. It might be helpful at some point, but we can go back and add it to check that box for adding Python to path statements. Not going to go into what those are yet. I'm going to click install now. And it's going to ask, it's going to probably pop up and say, are you able to install that? Yeah, it'll have a UAC of some sort. And so now it's installing. And we're close to getting there. Tick tock, tick tock, go little thing. All right. So now Python is installed on this system. And in fact, if I go to the Windows Start menu and I look for P, you should see, oh, look, Python 3.7. Obviously, we had Python 3.6. It does not just update weirdly. And there's some reasons for that, but there's a couple of different pieces in here then you'll see. And you'll see one called IDLE, and you'll see one called Python. The piece we are going to use almost exclusively is what's called the idle environment. And so if I click on it, it opens up, and it almost looks like a text editor, doesn't it? So this is what we call that Python shell. So it's not scary, very easy to use. And that's where we're going to head with Python. So this is kind of what we call a interactive environment. So things happen as soon as I hit the enter key. So here, I'm in the help utility. And if I typed print, more on how to print something. And so print really means in our programming environment that we're going to we are going to just output something. So if I print, notice when I type print even, it changes colors. So it says, hey, this must be a keyword. So I typed print, parentheses, hello, and it's going to output that print statement. So this is what we call the interactive mode. So what I do executes immediately. If I typed it like this and I said print, hello, now there's a subtle difference. In one, I put in quote marks. Quote marks says that's a text string, right? If I print hello and I just have it without quote marks, what is Python thinking that is? It's some kind of variable. Have we declared a variable or any output or name or anything else? No. And it's going to give us an error. It says, hey, we didn't define that. So error messages pop up in red. Other color coding, we pop up in various colors. So this interactive mode, it's pretty useful. We can put in one line at a time and you could run things. But it's not great when we actually write programs, is it? So it's pretty tough. If I go File, New, and when I go File, New, now it really does look like just a text editor, right? And so now I could print the same thing. So I could say print hello. And in fact, because I don't know yet how to do a loop in Python, I wanted to print that out 10 times. I could copy and paste it. And now that program we're storing it essentially as a text file. And so I'm going to go up here and I'm going to click Run. Because, I have my program here. This one executes as soon as you hit the Enter key, but I can only do essentially one line. This one says I can run it. I'm going to click the Run button. And when I do that, I get a couple of things. It goes, oh, let's go run the module. And this says I have to always save it. So much like if you're in web design or other courses, you actually have to save this file. So you're going to have to find a spot or a flash drive or whatever you're going to start using where you're always saving these to the same place. So by default, it's going to want to save it inside of my Python folder. And for this one, I'm going to just do that. And it's got an extension. So they're always .py, test.py. And so now when I ran it, it saved it, and it runs over here in my shell. You see that? So I run it, and it runs that over and over again. So that's your first program written actually in Python. And if I look at this file, so let me go, I'm going to save that where I know where it's going to be at. I'm going to save as, and I'm going to put it right on my desktop. And so, where did it show up? It shows up on the wrong screen. It's going to look like that, at least on Windows. That file, a couple of interesting things. I can actually now run it because it's embedded in there. If I click on it, it runs, but we haven't told you why yet, but when it runs, you see it flash on the screen and disappear. Well, that's not really useful, but we'll work around that. But I can also edit it with a couple of different things. So if you have Notepad++, notice I can edit it. I can put it in here. Notepad++ we use in some of our web programming. You can also edit it in. So if I come back to my desktop, I can edit that in just any text editor you want to. So open with, and I could open it with Notepad. And notice it's just a plain text file. It really is. So it's called a .py file. That just says that it's a Python file. We can edit it in either Notepad or we can edit it in the idle environment, or you can use another text editor like Notepad++. I don't really care which. There are some advantages to using something like Notepad++. One of the biggest advantages, notice over here, do I have any number? So tell me which line that is? No. And so this is one of the biggest advantages in a better text editor, is I know what line that is. So when we get a couple 100-line program and I get an error, I can quickly tell when the error message says go to line 5, there's an error. That helps me start to troubleshoot and debug. There's some other advantages, but for now, that's the biggest advantage you have. But that's the same program in all 3 different editors. So, same program. There we have it in, this is the native. I do not know, here's a good question, if I can multi-line tab, and I think I can. So, no, maybe not. I know I can do one line. Can I do two? Yes. So either one of these will do the multi-line indents. This program, Notepad, we know doesn't do that, right? It just goes, no, I'm going to delete it rather than do anything else. So, an advantage to either one of these. This is probably the best one to start out in just because it's easier to look at. There are some other things. We know we can run it directly from here. I can't run it directly from the Notepad++. So there's some differences and advantages either way, depending on how you want to look at it. But that is the same file in 3 different editors. If you're using it on a Mac, there's some other editors you can use. If you're using it on a Linux box, you can do all kinds of other things. The other interesting piece, and I don't know if we have any Linux users in here, you can actually run Python commands directly at your shell level. So it's useful for that. In fact, last summer, year before last summer, I guess 2 summers ago, I actually went to take a programming course put on by some Google programmers. Google uses Python internally for a lot of running scripts and running things. We use it in the security field a lot. We can build scripts very easily in Python. If you watch some of the shows like CSI or something, what they oftentimes are running when they show you they're running some little script and saying, we're searching for IP addresses and make up stuff, is actually Python. It's a really powerful, it's a great language for that idea of knocking out a very quick script to run something. If I want to check the conditions of things, I want to run a script that will interact with my thermostat, I can do that really easily. It's very powerful, very easy to use, and it doesn't look like computer programming. It looks in a lot of cases like English language. And so it's really easy to knock it out. And so when I took that course from Google up at Iowa Western, those programmers at Google, what they used it for, or at least what they could tell me, because they're very secretive about what they actually do at Google, obviously. But they use a lot of these for monitoring, controlling. It's not running your web search, but it's behind the scenes. They're able to fine-tune their machines and their system and look at it with Python. So it's powerful. We're going to probably not get to the point of building something quite like Dropbox, but it's certainly possible. You can do those kinds of things. Go to python.org, download and install this so you can get it up and running. But look at those success stories. Look at different companies, what they're doing with it. Look at the jobs that are available. There's some pretty decent jobs out there running this and other languages. And a lot of the jobs you'll see list multiple languages. They'll say they want PHP plus this language. But we want to get work through where you can start doing some programmatic elements. And really, all we're going to do is we're going to do sequences, selections, and our loops. That's it. Those are the 3 pieces, and we're going to use them inside of Python. All right, any questions? Anybody scared of Python yet? It looks really safe, doesn't it? It's not a scary snake. No questions? All right. There is some homework this week. If you haven't found it, you should. So make sure you do the homework. I have asked, and I've already had a couple that turned it in. So this week you have 1 debug program. Before you do anything else, what do I see wrong with that? Not even looking inside the code. What's wrong with that? There's no indents anywhere, is there? So that tells me that's all 1 block of code, but I can see when I look at it, I see some loops, don't you? And we know that anything that's supposed to run inside that loop would be indented, so I will give you a hint there. So this half of your assignment, the debug problem, is worth half or 10 points, and then there are some multiple choice questions in there that we'll look at also. So similar to what we did last week. So make sure you start early. I will send out an announcement, and your due date will actually be Monday at midnight. There is going to be a lot of Super Bowl parties, and while I support neither team, darn you, Chiefs, for once again breaking my heart. I realize that a lot of people will be involved in all kinds of activities. I probably won't be able to concentrate and send you really great answers that day. We're going to a Super Bowl party at somebody who's apparently is the only Patriots fan I've ever met. I used to have respect for him, and now I've lost all respect. They're having a Patriots party. So it should be exciting. There'll be about 20 of us non-Patriots fans and one Patriot fan. So I feel sorry for poor Greg. All right, guys. Any other questions? Comments? Great stories about freezing yesterday. Nothing? It was nice and warm. Everybody survived. Your car wouldn't start.
Yeah, my car didn't start.
Your start.
But I'm on campus.
Oh, so that wasn't that
I
bad.
still made it to work. So
You made it to work, even?
Yeah.
Now I do feel sorry for you having to go to work. All right, guys, let's get out of here. Have a great weekend and go Rams, right? Yeah, hang on a second. Let me hit the stop button.